Hello everybody, I want to do one more video here real quick. Still working with my class here with Adam and Brittany, Shelby and Grayson. And we want to talk a little bit about what we call a dot product. And so we're going to work with Shelby and Grayson again here. A dot product is a way of multiplying vectors, one of two different ways, and we'll get to the other one in another video later on. But we want to talk about multiplying by the dot product. And we symbolize that with a dot. So we'd have the position of Shelby dotted with the position of Grayson. And so I use a little dot here in the middle. When I do this, I'm going to get a scalar quantity. That is to say, I'm going to get a number that doesn't have any i's and j's. But the way I get it is I multiply the I components together. So I have negative 4 and 2. So negative 4 times 2. And then I'm going to multiply the j components, and I'm going to add that onto the I. So I'd have negative 5 times negative 6. All right, so negative 5, negative 6. And when I'm all said and done here, I'm going to get negative 8 and positive 30. And so the answer to this is 22. The dot product between Shelby and Grayson is 22. Note if I did Grayson times Shelby, I'd get the same thing. Right? So this is equal to the position of Grayson dotted with the position of Shelby. The dot product is commutative. The dot product is commutative. And that would just be 2 times negative 4 and negative 6 times negative 5. You'll get the same thing. The other thing this is equal to, when I do the dot product of Shelby's position times Grayson's position, it's equal to the magnitude of Shelby's position, which I'm going to write this way, the magnitude of Shelby's position. So I put that in absolute value signs. That means magnitude. All right, and the magnitude of Shelby's position was the square root of 41. If you recall from the previous videos when we put this up in polar form. And then I multiply that times the magnitude of Grayson's position. So I'll just write that as R sub G with an arrow over the top with an absolute value sign. And that was the square root of 40, as you might recall. Then times the cosine of the angle between those two vectors. And so I'm just going to write SG. The cosine of the angle between Shelby and Grayson. So if I go back onto this map, that's this guy right here. Right? This is theta SG. That's the angle between Shelby and Grayson. That's the angle between Shelby and Grayson. I don't know what that angle is right now, but it's going to be the cosine of the angle between Shelby and Grayson. But remember, the dot product is 22. All right, so if I take 22 and I divide that by square root of 41 and the square root of 40, so 22 divided by the square root of 41, square root of 40, okay, that's going to be 1640. I think that's right. So this would be the square root, or this is going to be 22 over the square root of 1640. And that's going to equal the cosine of the angle between Shelby and Grayson. The cosine of the angle between Shelby and Grayson. And if I do that, I'm going to come up with the angle between Shelby and Grayson as being equal to, okay, I've got to get my calculator out. I've got to figure out what all that's going to be. But if I do that, I'm going to get 57.4 degrees. If I did all that correctly, I'm going to get 57.4 degrees. Right? And so if you take the cosine of 57.4 degrees, that should equal 22 over the square root of 1640. And that's how we do a dot product. A couple of different ways. This is how we do it by components, and this is how we do it by angles and magnitudes. The beauty of the dot product, again, it gives you a scalar quantity. There's 22 is a size, no angle. There's no angle in there. I can get it with an angle, but I don't have an angle in the dot product itself. But it tells me the angle between those two vectors. And this is going to be true for angles in 2 or 3 dimensions, doesn't matter. They'll always be, there will always be a way of finding the angle using the dot product. and it's very powerful for that. It will always give you the angle in between less than 180. So for example, if I did the dot product between Adam and Shelby, it's going to give me this angle in here, not this angle out here. It's going to give me the angle less than 180 degrees, not the angle greater than 180 degrees. All right, that will always be the case. You can figure out what the other angle is, just subtract it from 360, but that will always be true. This becomes really powerful in 3 dimensions because those angles are much more difficult to calculate out than they are in 2 dimensions. All right, so there's just a real quick review then of the dot product, or introduction actually to the dot product, and we'll go over this in more detail in a little bit later video. All right, if you have any questions, please put them in the comments below. Thank you. All right, quick addendum to the video that you just watched, right? I told you that the angle between Shelby and Grayson was 57.4 degrees. I got that from Shelby's position being minus 129 degrees, and Grayson's position, Shelby's angle is minus 129, Grayson's angle was minus 71.6. Subtract those out and you get 57.4. But there's a round off error in there, which is cool, because if you actually do 22 over the square root of 1640 equals the cosine of the angle between Shelby and Grayson, you're going to get 57.09 degrees, not 57.4, more like 57.1. But that's because I wrote down minus 129 degrees for Shelby, but really if I take that out more digits, I get minus 128.66. And for Grayson's, I had minus 71.6. And if I take that out more digits, I get minus 71.565. So this, and then if you subtract those, you're going to get something closer to 57.09. What I like here is that it shows you that taking out lots of digits and then rounding off, when you use those numbers in later calculations, don't use the rounded off numbers like 129. Use the original numbers like minus 128.66. Don't use something rounded off like minus 71.6. Use minus 71.565. Because if you use rounded off values, you'll get errors in the final value. 57.4 is 3 significant digits. 57.1 is 3 significant digits. But this is wrong, and this is right. This is more accurate. This is off a little bit to 3 significant digits. So it's a really good lesson for me to go over that. So I'm adding that onto this other video. So anyway, pretty cool. So keep an eye on the number of significant digits you're working with. All right, if you have any questions, put them in the comments below. Thank you.